Hello, everyone. Thank you very much for joining this webinar on CockroachDB for retail. Hopefully, by the end of this, you'll figure out the tools and tips you can use so that you never oversell a product again. It is geared towards retail, but I think a lot of the lessons that you learn in today's session will be very much applicable for a lot of use cases and workloads that you might be dealing with. So I'm Rob Reid, Technical Evangelist at Cockroach Labs, and I'll be hosting today's session. Please use the Q&A function if you have any questions at any time. I'll keep my eyes peeled for the questions as they come in, so feel free to submit at any time. We'll be recording the session and sharing slides and video out over the next couple of days. And if you get the chance and have the time, we'd really appreciate it if you could feedback via the survey after, so that will help us inform what the next sessions need to become. So a quick intro on CockroachDB before we get going. I can't assume that everyone is going to be familiar with CockroachDB, so I'll do a quick whirlwind tour. CockroachDB is a distributed SQL database. It's familiar if you're coming from other relational databases. So if you are coming from other relational databases, CockroachDB will feel familiar to you. You don't have to speak CockroachDB in order to interact with it. You'll be using a familiar Postgres SQL syntax. When it comes to scaling, CockroachDB horizontally scales for both reads and writes. You can expand or contract the cluster, and it's kind of a non-event, and that's reliably the case. There's no sharding required. You just add nodes, and CockroachDB does the scaling for you. You can scale across regions. You don't have to, it's not confined within a specific region or AZ. You can scale beyond the borders of a country or cloud providers. You can run across cloud environments or on-prem infrastructure if you have it. And so essentially, it can be deployed practically everywhere. CockroachDB is a binary. It doesn't really mind where it's being run. And it's highly resilient against failures, which makes upgrades very straightforward. In this slide, we're running a version of CockroachDB 23.1.11, and I'll simulate what happens when you upgrade to 23.2. So we would knock out nodes, and because CockroachDB can survive downtime, it's a natural way for CockroachDB to be upgraded. It will note that it's in mixed versions if you are running mixed versions of CockroachDB, and once all of them are upgraded, the cluster version would be updated in accordance to that. And it can survive failures. Data is replicated across machines, so surviving outages becomes a non-issue as well. You can survive node, AZ, region, or if you're running across multiple cloud providers, an entire cloud outage. And you can pin data to geographic regions. And this helps with things like regulatory compliance or keeping read and write latencies for users in all locations low. And it's all from one database. This is one logical and physically distributed database. So essentially, if I had to wrap up, CockroachDB provides the best of all the database paradigms. It was built from the ground up to be a distributed SQL database, meaning that transactions is distributed, horizontal scalability is effortless. It's self-healing, so in the event of an outage, it will come back up and self-heal itself, and data residency requirements can be achieved. So why CockroachDB for retail or inventory management? Whenever your business isn't online, and this is more specifically to retail, it's not making money, and in some cases, it's just costing you money. So that downtime can be calculated as a monetary loss. For medium-sized businesses, the average cost of downtime is around $9,000 per minute. As the size of the business increases, so does that cost. A large-sized business, on average, will lose around $6,000 per minute, while some of the largest enterprises can be losing about $1 million per minute for every minute that the application is down. So CockroachDB helps you towards the requirements for zero downtime and offers maintenance without interruption, which means no more customer frustration while your team work to upgrade hardware or software. And retail sales are often a case of feast or famine. In some quiet months, your retail business might not be making much money, whereas over Christmas, July sales, or Black Friday, it could be a boom month for your business. So you really need to capitalize on those opportunities. Off peak, you might be making $10,000 a day, and that might be tenfold in seasonal peaks, and maybe a hundredfold on Black Friday. It all depends on your vertical, your business, and the type of customers you have and their behaviors. If you can't support fluctuating sales across these seasons, your business won't thrive, and your customers might find somewhere else to shop simply because your app or website becomes too frustrating to use. CockroachDB in this case can help you thrive when demand is spiky and help you capitalize on short-lived opportunities. and scale elastically so that you're running efficiently when demand is lower. Strong consistency is table stakes for any application, and retail is no exception to that. And if your database isn't consistent, you might be reporting inaccurate stock levels. A customer might come to their basket at checkout and find that they've got no products in their basket because of a consistency issue. Or you might fail to account correctly. You might be missing, you might invalidate your balance sheet simply because of consistency errors. CockroachDB can guarantee that you never oversell a product because of its strong consistency, serializable isolation guarantees that give you that will ensure that you never leave customers disappointed at checkout, and it gives you trust that your accounts are going to be always correct. Your application should feel local to everyone. It should feel like a local website, regardless of where your users are in the world. And historically, the stateful parts of your application have been the most difficult to scale and distribute geographically. With Cockroach, you can scale the stateful part of your application into new markets and reach new customers. And it's as simple as adding new nodes to the cluster. So multi-region allows you to achieve low latencies, harnessing various table topologies for different tables to give all users of your application a really good experience. It's maintainable. I like to think of CockroachDB as it centralizes the management of an inherently distributed system. It should feel natural. You can configure tables in CockroachDB such that they exist everywhere, which we'll talk about in a minute. And things like translations, that's really helpful. And you can reach new customers really easily. So CockroachDB distributed architecture provides low read latencies for everyone, wherever they are, and can help you enter new markets without embarking on month or year-long projects to do that. And talking about centralized management, we arrive at the fundamental simplification that Cockroach provides retail businesses. And that's this. I've lived this personally, and I can speak to the benefits of this architectural simplification. So when you can deploy a single logical database across geographies, you're managing less infrastructure, you're managing less moving parts, you're managing less complexity. A global business rule can be applied in one statement. You're not having to do different business rules for different locations. Upgrades can be performed in one operation. You can update the whole cluster in one fell swoop. And the whole system works together to give you scalability and resilience against failure. So in the before scenario, we're managing 9 different things. We're managing 3 separate database instances, all that need to be updated, patched separately. We're managing 3 separate applications, all of which need to be deployed and maintained separately. 3 separate connection strings, all which need to be maintained, and the opportunity for config creep is there. The after scenario, we're dealing with one database, one logical application that's distributed. Obviously, that's an application concern, not a database concern. But previously, this database tier aspect of it has not been possible. A geo-aware load balancer. Obviously, if you want to have one connection string to manage, you can use a geo-aware load balancer, which routes customers to their nearest CockroachDB region. And then we're going to data placement. So historically, you've had to make a choice as to whether you let your customers down or your back of house staff. By having a single location for a database, either you made your customers unhappy because they were far away from the application and the database, or you made your staff unhappy because they were having to manage something that was close to the user, but not geographically close to them. In this scenario, the US staff are happy because they've got a database and application that's close to them, whereas they're a US-based startup with EU-based customers, and the customers are miles away from the database. They're having to make long round trip times to get at their data. And it's exactly the same if the reverse is true. The worst case scenario, and it does get worse, is if you have an EU-based customer, but you believe that you need to store their data locally to them, but the application is still running out of the US. That's probably a worst case scenario. The application makes a request, the user, makes a request to the application. And in this case, that's a 5,000 kilometer hop across the pond. The application talks to the database. That's another cross pond hop before being returned to the application with the data and then back to the user. So that's 4 cross pond hops totaling 22,000 kilometers for one single request. Obviously, users make lots of requests to the database, so their whole experience of this application is going to be very, very poor. So co-locate your application and your database close to your users in retail and in other environments as well. Retail isn't the only environment you'd want to do this. Users are close to the data they care about. And the application and co-location of database is super important. All of these users will be making super short hops to their database, and they'll be getting low latency reads and writes as a result. So at this point, you might be thinking, if you're running a globally distributed database, there's going to be latency somewhere, and you're not wrong. That's completely acceptable. And you can't beat the speed of light, but with the right table topology patterns, you don't have to. So I'll talk about some of the table topology patterns that you can harness in CockroachDB to remove the need for that. Follow the workload is the default topology pattern for a database in CockroachDB if you don't specify a locality. And essentially, it shifts around what we would call the leaseholders, the things that control reads and writes to chunks of data, such that they are always close to where they're being used the most. So, for example, if you have users in Singapore that come online before users in Europe and then before users in the States, those leaseholders will transfer across the globe reliably throughout the course of the day. Obviously, if your application follows this reliable follow the sun model, then it works great. If your users are online all the time, perhaps not so much, but there are other table topology patterns that you can use for that. Then there's regional tables. In the example where we have a US-based business orchestrating a business from the States, they can use regional tables. So for example, you don't need to have all of the data everywhere. You might just want to have table data in the States where it's being used by back of house United States employees. It doesn't have to be everywhere. Regional table topology is good for that. Then we have regional by row. That's where you can achieve low read and write latencies for everyone who's accessing the entire database globally to their local region. So users in US East 2 will get low read and write latencies to their closest region. So will users in Frankfurt, and so will users in Singapore. Then we have global tables. This is the same data that's replicated globally. This is good for reference data or data that is read frequently, but written to less frequently. So we're going to go on to a couple of demos now. I've recorded them because I found that it's much easier to fast forward video than it is to fast forward real life, and I don't want to have you waiting for me. So I'll click this, and what we'll see is a demo of a globally distributed e-commerce simulation that we've created that will show you what kinds of experiences you can expect from a globally distributed CockroachDB database. I'm building this atop Fly with one of my colleagues, Adrian. We built this in CockroachDB and Fly.io. Fly is a very easy to use application hosted provider, so that's why we used that. Although you can do exactly the same in any of the cloud providers as well. So I'll click play, and what we see is I'm talking to the United Kingdom region, and I'm seeing read latencies of around 13, 14 milliseconds. And that's because I'm co-located with my database. If I access products in Germany, I'll get higher latencies, US higher still, because I'm making a cross-pond hop. If I was in the States, I would be close to the States, and I'd be getting really low read latencies from there. I can switch the language, and the translations, as mentioned earlier, are being stored in a global table. So regardless of whether I have Japanese users in the States or US-based citizens in China, it doesn't matter. The data is close to the users. The next demo I'd like to show you is one specifically around inventory management. So I'm spinning up a globally distributed database and application again, but this time I'm simulating users interacting with the database, browsing for products, adding products to their basket, and then finally checking out. The checkout takes a little bit longer, as you'll see from the logs. We're going to be tailing log files for this, and that's simply because it's a very heavy operation. I'm performing 7 separate queries as part of this. One to check that the customer's basket has products in it. Another to perform a last stock check before we check out the products. One to aggregate basket products into a collection. One to sum up the total of all those products. One to record the customer's purchase in a ledger. One to remove the stock from the stock table post the transaction going through. And then finally one to clear the user's basket. So I'll kick that off. And what we're doing is we're running a Cockroach cluster across 3 regions. It'll be across US East 1, EU Central 1, and AP Southeast 1. So it's across the world. I'll set a request units per second to an arbitrary count of 5,000. That's kind of irrelevant here, but you can set it depending on your workload constraints. I create the cluster. I'll speed this up. It takes about 30 seconds to spin up a CockroachDB cluster like this. And then for the SQL developer user, I haven't changed the username. I generate a password, and then I'll copy the connection string to my clipboard. With that copied, I export a bunch of environment variables. All of these you can screenshot it if you like. All the values have changed since then. I hop onto the terminal, and then I create the database tables and functions that I'll be using for this. I've sped this up just so that you don't have to wait on that. I then expose my computer to the internet because I'll generate a bunch of data, which I'll import into the CockroachDB cluster, which you can see happening now. So there's 1,000 customers, 1,000 products, 15,000 market products. That's 5,000 for each. 15,000 stock units, 1,000 basket items, and 15 lookups against regions. I then deploy the application to fly.io. And at the bottom, you'll see that I'm monitoring for logs. So the logs are coming through now. The Frankfurt region has started up. And what we're seeing is browse latencies. They'll settle down to about 10 milliseconds for product browsing. That's selecting products between a particular price. Basket latencies of around, they settle down to about 12 milliseconds. And then checkout latencies, which we'll see in a minute, in about 20 seconds, they hover around the 60 millisecond mark. So these units of time are generally completely imperceptible to users. So that if there's anything else in the way of that, so network latency elsewhere, at least the database and application are performing with very low latency. So there's the checkouts, and that will be depleting stock in the background. All with serializable isolation, so we're guaranteed not to be overselling products. The same for, I think we just skipped past this checkout, so 60 millisecond checkout for Virginia-based users, baskets around 12 milliseconds, and browse times of around 10 milliseconds. And now we'll look at a simulated Singaporean user. Checkout times of around 50 milliseconds, basket times of around 10, 11 milliseconds, and browse times of around 5 milliseconds. So this is the kind of experience that all users are getting across the world for our one single database. So just to recap on the demo, we've just spun up a globally distributed application and database, and it's taken around 30 seconds, obviously in real time. Data is pinned to locations to help with data locality regulations so that the regulators are happy with our application. Data is close to the users, providing low read and write latencies, so our customers are happy. And the stack is extremely simple, so our developers are happy. The QR code that you can see here is scannable, and that will take you to the application so you can try it for yourself. If you're based in the US, I would expect much lower latencies to the US market, where data is physically coming from the US, than I would from, say, Frankfurt or the UK. So this is a globally distributed simulation of an e-commerce system that has support for inventory management. And everything, it's probably worth noting that when you try this after 15 minutes, everything in the Roach Roast application, right from the front end all the way back to and including CockroachDB, is running on serverless technologies. So the first couple of requests might take a little bit longer than the rest. So in short, and this has been a very short webinar, you can run a global e-commerce business and you can do it safely without overselling a product with CockroachDB. With that, I'd like to thank you. We've got questions via the Q&A function. So if you have any questions at this point, please feel free to submit. So I've just had a question here. So someone's saying, couldn't I just run a separate traditional database across each of the regions my business operates? I think that's a really good question, and thank you for it. So essentially, you can absolutely do that. But then the things you're looking at managing in terms of, let's say it was a Postgres database. Postgres is obviously a phenomenal database, and I don't think we would be here if it hadn't been for Postgres. Postgres in this scenario would need to be horizontally sharded in order to be horizontally scaled. You can only scale a Postgres node as far as one machine can take it before needing to shard it manually. And that involves, so that would be for one market. But if you wanted to then enter separate markets, you're then looking at a separate Postgres cluster that you would need to then maintain separately, patch separately, and then shard and horizontally scale all separately. I've actually got a YouTube video of me doing this because I've historically said sharding a database manually is hard, but it's only been anecdotally. But I've given it a go myself, and I can happily report that it is much harder than I was expecting. And by the end of the journey or adventure, I was left with a broken Postgres instance, which kind of only sort of worked. So what Cockroach gives you is the simplicity of scale without you as the operator or the developer of the database and application having to worry about, have I sharded this in the correct way? Will I achieve the right amount of scale given spiky workloads. It's all handled for you. I hope that answers your question. I'll wait for a little bit longer, see if there are any other questions. Oh, we just had another one. What are the biggest challenges that retail businesses face today? Okay, more of a business question this time. I think a lot of the challenges that retail businesses face are the same as a lot of what other verticals do face as well. But particularly in retail, I would say spiky workloads because everyone's online. And as we saw with things like Ticketmaster for the Taylor Swift Eras tour, scale can be enormous when it comes to online activities. Black Friday can be enormous and can vastly outpace the scale at which you've been testing your application or which you've historically seen in your application. So I think scale is probably one of the biggest concerns for retail businesses. Certainly when I was in retail, scale was of paramount concern to us because some businesses can be seasonal and sales patterns can fluctuate, and if you're not capitalizing on the busy periods, you're not going to be making as much money as you might otherwise be able to if you were able to satisfy that level of scale. So having a database that scales horizontally, that allows you to add nodes through busy periods and remove them carefully afterwards. And I say carefully because if you take away a CockroachDB node, data will be rebalanced, and you want to make sure that rebalancing happens before you remove other nodes. But you can scale up and then scale back down with very little effort. So I'd imagine scale is probably the biggest concern. Then you've got security. As soon as your business is online, you're probably going to be the target of someone else. So someone else is always going to want what you have, whether that's your customer base, whether that's their emails or passwords. So with any database, and CockroachDB does this as well for you, I would recommend that you are using hashing where appropriate and encryption where appropriate as well. Encryption in transit is massively important. Encryption at rest is also very important. CMEX as well. If your data is stored in the cloud and you have access, you control the keys that are being used to encrypt your data. If that data is then called up by, let's say, the US government for reasons of national security, at least you've got the keys and you can decide as to whether your customer data can be served up for that request. If it's using the built-in cloud-based keys, they can decrypt your data and send it off on your behalf, not necessarily without you knowing necessarily. So I think those are probably the two main things I'd focus on. There's another question here. Can you go into more detail on spiky workloads? I mentioned it briefly, but how does CockroachDB handle sales like Black Friday? Oh, I've started to talk about it. So yeah, a good question. So it depends on how you're running Cockroach. So there are cloud-based or managed services that you can get with CockroachDB, in which case it's just a simple case of tweaking a configuration to say, at this point, I want to, let's say, add 3 more nodes to my cluster to help with scale. And what CockroachDB will do in that case is scale from your current node count. It will add nodes to that cluster and then rebalance the data across those nodes so that they're all participating in both reads and writes. So that will help with your scale. If you're self-hosting CockroachDB, so you're running it on your own infrastructure, you can perhaps set up, if you're running it in ASGs, auto scaling groups in AWS's case, you can schedule the number of ASGs or the number of requested or desired instances to go up at specific times and then come down at others. If you're automating the tail off or the scale down of that, I would advise caution about automating that. Just make sure it's staged, just so you don't suddenly take out half of the cluster under CockroachDB's feet, in the same way you wouldn't want to do that with any other distributed system. So that's probably what I'd say on spiky workloads. Another thing is to test your applications, and obviously that's a no-brainer. But I've fallen victim to this in the past by not testing the database with production scale data. That will highlight issues with missing indexes. It will highlight issues with bottlenecks when it comes to user behaviors and performance. So use something like K6 or Artillery or anything. JMeter is another good one. Simulate users, simulate what a good business day looks like for you, and then double it, and then run what you would perceive to be a Black Friday sale. They're called, some are called soak tests, some are called load tests, some are completely unreasonable loads. But it's important to know how your database reacts and how your database gracefully fails when it gets to that absolute breaking point. Just know how your application and database are going to behave. I actually ran a webinar last week on exactly this, which we'll add to the link for this video as well, based on database performance. If there aren't any other questions, we can call it there. I'll just hang on for a couple of minutes because we've had some really good questions so far. Okay, I think that might be it for now. Thank you all so much for joining. It's been a pleasure talking with you, even if it's just one way. Once we've hung up, you'll be sent a link for a survey feedback link. Please, if you do get the time, fill out the survey because that will really help us with the next webinars to deliver content that is relevant for you. Take care of yourselves and hopefully see you at the next one.